Alright, hello everybody. We're going to look at rational functions. So first, a rational function r of x is a function that can be written as p of x over q of x, where p and q are both polynomials. So a rational function is a polynomial over a polynomial. So since we have division, we have to worry about the domain. So the domain is all real numbers except for which the bottom turns into 0. And then in this section, what we're concerned with are the vertical and horizontal asymptotes. So a vertical asymptote is at x equals r if r is a real value, is a real 0 of the bottom, and the rational function itself is in lowest terms. Horizontal asymptotes. If the degree is bigger on the bottom than it is on top, then you have one at y equals 0, because this is horizontal, so it's y equals. Where vertical asymptotes are x equals something, because they're vertical asymptotes. If they have the same degree, then you have one at the coefficients. And if the degree on top is exactly one more than the bottom, then you have what's called an oblique asymptote. So let's take a look at a couple examples. Okay, here I have a rational function. I have a polynomial over a polynomial. So first up, let's find the domain. Okay, so here I want to know, I'm going to take the bottom and I'm going to set it equal to 0. I'm going to find out all values to make the bottom equal to 0. So this looks like, what, x minus 6 and x plus 2. So I have x equals 6 and x equals minus 2. And those are the values it cannot be. That would cause division by 0. So my domain is a collection of all x's such that x is not equal to minus 2 or 6. Or interval notation wise, I'm going to draw your number line. Here's minus 2. We got to rule that out. 6, we need to rule that out, but everything else is okay. So depending on what it asks you for, the interval notation would be minus infinity to minus 2, union, minus 2 to 6, union, 6 to infinity. That's the domain. You always just look at the bottom, factor it, set it equal to 0, and then that's what it cannot be. Okay, next up. Let's find the vertical asymptotes. Mess up some more space here. Okay, so let's find the vertical asymptotes. So remember, it's got to be in lowest terms. So what I'm going to do first is I'm going to simplify. So this goes back to simplifying rational expressions. If you've forgotten, then go watch that video. But I'm going to simplify x squared minus 4 over x squared minus 4x minus 12. What I'm going to do is I'm going to factor. So I factor the top, that's a clear difference of squares. And the bottom, we already know how it factors, x minus 6, x plus 2. And now it's in lowest terms. Okay, and then now for my vertical asymptotes, any value that makes the bottom turn into 0 once it's been simplified. So my only vertical asymptote here is x equals 6. That's my only one. I do not have a vertical asymptote at minus 2, although that it still screws up my domain. So for domain, you just set the bottom equal to 0, and whatever causes it to be 0, you got to rule that out. But for vertical asymptotes, you got to see if there's anything you can simplify, in which case that should not be a vertical asymptote. Okay, next up, let's find the horizontal asymptote. Okay, for the horizontal asymptote, there I play where's the biggest power, and here it's a tie. The degree up here is 2, and the degree down here is 2. So my horizontal asymptote is going to be the coefficients. So there's a 1 in front of this x squared, and so is this. So it would be 1 over 1, which is 1. But if, for example, this was 2x squared on the bottom, then my horizontal asymptote would be y equals a half instead of y equals 1. Here it's 1 because those are my coefficients. When it's a tie for biggest power, then it's just the coefficients. Okay, let's take a look at another example. Okay, so here's a rational function. It's a polynomial over a polynomial. We're going to find the domain, any vertical and horizontal asymptotes. So first, the domain. Okay, all I'm concerned with is the bottom. So take the bottom, set it equal to 0, and I solve. Factor. So I get x cannot be minus 4, and x cannot be 4. So domain will be a collection of x's such that x is not equal to those two values, and everything else is good. Second, the vertical asymptotes. So I'm going to rewrite x plus 3. I'm going to factor the bottom in hopes that I can cancel something out. So there it's in lowest terms, and nothing cancels. So in this case, I have two vertical asymptotes. I have a vertical asymptote at x equals minus 4 and x equals 4. And 3, the horizontal asymptote. So here the biggest power is on the bottom. Whenever the biggest power is on the bottom, you automatically have a horizontal asymptote at 0. Okay, let's take a look at one more. Okay, let's look at this one. I'm going to find the oblique asymptote. I know there's an oblique asymptote because the degree up top, it's, oops, get rid of that real quick. Sorry about that. The degree up top is 2, and the degree on the bottom is 1. So to find the oblique asymptote, what you do is you do division. So I'm going to take the 3x minus 2 and divide it into the 6x squared minus plus 7x minus 5. So, alright, here we go, long division. So what I need to multiply 3x by to get to 6x squared. Then I need a 2x and multiply to everything. 6x squared minus 4x. Change my signs and add down. This gives me 11x, bring down one term. What do I need to multiply 3x by to get to 11x? So this one's a little tricky. I need to get an 11 out of a 3, so I need to multiply it by 11 thirds. So that's going to give me 11x minus, this is going to be 22 thirds. Change my signs and do addition. These guys cancel. And then minus 5 plus 22 thirds, put this over 1. Multiply this by 3, top and bottom, find the common denominator. This is minus 15 thirds plus 22 thirds, which gives me 7 thirds, and that is my remainder. So plus 7 thirds over 3x minus 2. And then this is our oblique asymptote. So we have an oblique asymptote at y equals 2x plus 11 over 3. Oblique asymptote is always going to turn out to be a linear function here. And it's whatever, when you do the division, it's whatever you get here. And again, if you think about x as getting very big, this term, if you look at this, you have one degree on here is bigger on the bottom than on top. This term's going to go away, and this is the guy we have. This is your oblique asymptote. Alright, and I think that'll be enough to get you started on 5.2.